Okay, guys, lesson 37. As we look at lesson 37, okay, you'll notice the title says differentiation by use substitution. You'll also notice it's crossed out and it says chain rule. So it comes down to there's different ways we can talk about this. And I will kind of hint at the idea of use substitution in a way, just kind of, using the idea of a substitution. But really we're going to talk about what we call chain rule. Okay? As I said, kind of mixing the concepts today. We'll have another lesson a little bit down the road that is also chain rule. So when we talk about differentiation by substitution or chain rule, it's more derivatives. And it's kind of another add-on to the derivative rules. Okay? We already have our basic derivative rules. We have our product rule, which our product rule we have to use when we have one x value times another x value, where we can take the derivatives of both. We have to employ that product rule, where it's derivative of one, keep the other, plus, and reverse the situation, right? Well, now we've got a chain rule. And the chain rule is kind of the idea of when there's a derivative within a derivative that we have to look at. Okay? So that's the exponents within exponents that are making these a little nervous. Okay? As we look at the idea, for instance, so basically the idea of U substitution. Y equals e to the x squared plus 2. What's the basic derivative rule you know to use it? Is y equals e to some power, yes? And the idea of y equals e to some power is the derivative of y equals e to some power is e to that power, right? But the chain rule is going to add another piece onto that, because when we've been doing the derivative of e to the x, it's just e to the x, right? But that's when the power is just x, when the power is something other than x. We have to consider the chain rule. So when we talk U substitution here, e to some power is like e to u. Here we have x cubed minus 2x squared plus 1 raised to the power of 100. Well, what's the overall outside thing happening there? And that's the idea that it's some base, right, raised to some power of 100. Can you take the base of something raised to a power of 100? In other words, if we think of this as u to the 100, can you take the base of u to the 100? Yes, you can. Now, the chain rule means we're also going to take the derivative of the inside. I'll get to that in a moment. Right here, natural log of x squared plus 42. What's the overall form we're taking the derivative of? Natural log of something. Well, you know, the derivative of natural log of something is 1 over something. Notice I keep using the word something. Okay, that'll be important. Sine of x squared minus 15. Well, overall big function there is sine of something. So sine of u. And then this last one, sine x raised to the third. Well, again, we're looking at the overall big function. That is something raised to the third power. And those are all things we can take the derivatives of. But they're also, the way these are left written, all things where there's also an inside function we'll have to take the derivative of. Okay? So, let's talk about this section right here. The derivative of many functions can be found using, it says use substitution there. But as I said, I'm also going to talk about the chain rule concept. Because that's what it essentially is. Okay? So it's all chain rule concept. This will be a key fact right there. Okay, so, written out. This is good notation to understand. Given f of g of x. So given where you have one function plugged into another function. To take the derivative, this is what we do. We're going to do the derivative of the outside function, keeping the inside the same. And then multiplying that by the derivative of the inside function. So that's what this is saying when it's f prime of f of g of x. The derivative of the outside, so f prime of g of x times g prime of x. In words, the derivative of the outside function, keeping the inside the same, and then multiplying by the derivative of the inside. That's the gist of what we're going to be doing here. Okay? Now, we can look at Nathan's favorite example over there. Sorry, Nathan, I keep picking on you there, but he was going to complain about exponent and exponent. And I get it, they're not as pretty anymore, are they? If we had y equals e to the x squared plus 2. So we talked about e to some power, right? What's the derivative of e to some power? Still e to some power. So the derivative of e to the x squared plus 2 is e to the x squared plus 2 times, can you take the derivative of x squared plus 2? The derivative of x squared plus 2 is what? 2x, in addition you say plus 0, but 2x. So that 2x represents the derivative of the inside. And then this is just rewritten form where putting the 2x out front, this derivative can be written as 2x e to the x squared plus 2. Okay? Ready to try some examples? Let's look at example 1 here, see what we can do with it. If f of x equals x squared plus 2x raised to the 10th, what is f prime of x? Now, one thing I'm going to try and do is I want you guys, as we get used to this, talk to me about what is that outside function. Okay, something to the 10th. Okay, so when we talk about that outside function, it's something to the 10th. So if for the moment, this is kind of where our heads are thinking, if we think it's something to the 10th, so it's u to the 10th, what is the derivative of u to the 10th? 10u to the 9th, yes? So y prime here is 10u to the 9th. Now, the difference is r is really a u. Now, so what we're going to do is we're going to do the derivative of something to the 10th. And then we're going to say times the derivative of whatever that something is, or the derivative of that inside. So when I write this, f prime of x. So over outside function is something raised to the 10th. So instead of saying 10u to the 9th, I'm going to say 10 what? 10 x squared plus 2x raised to the 9th. So that's taking the derivative of the outside, leaving the inside the same. Now, not done now. Times what? The derivative of the inside, or the derivative, you can say something raised to the 10th. The derivative of that something. What's the derivative of something? Okay, so in other words, the derivative of x squared plus 2x is 2x plus 2. Now, depending on your situation, you could possibly answer with this. Okay, this is an equivalent final answer. When we go to check this lesson in the answer key, this Saxon calculus book tends to not leave the answer like this, so I just want to show you some equivalent forms. And I always like to show you equivalent forms because the AP test is half multiple choice. If it's half multiple choice, you need to be able to identify an equivalent answer. Does that make sense? So, what you can see here, look at this 2x plus 2. What do you know about 2x plus 2? It has a GCF of 2. So if there is a GCF of 2, and notice what else is already out front? That's 10. If If you factor out that GCF of 2, and there's already a 10 out front, what is 2 times 10? 2 times 10 will be what? 20. So this can be written, if you bring that 2 out front, multiply by the 10, 2 times 10 is 20. And the rest I'm going to leave as is. It's x squared plus 2x to the 9th times, now what does 2x plus 2 become since I factored out the 2? X plus 1. I was just going to go there. I had the question come up. So the question was, can I factor an x out of the x squared plus 2x? You could factor an x out of the x squared plus 2x, but if you factor that x out of those parentheses that are raised to the 9th, how many x's are you really factoring out? Maybe an x to the 9th that would end up being out there. Does that make sense? Because if I take just an x out of this parenthesis that is raised to the 9th, you would have to put an x to the 9th out here, which you could do. Okay, we don't normally see that, but that doesn't make it impossible. Okay, so if we can rewrite this as 20x to the 9th times x plus 2 to the 9th times x plus 1. That is acceptable, just realize it's not just an x that goes out there. You have to pull whatever power it is with it. Other questions? Let's try doing example 2 then if you are ready. If h of x equals the cube root of x squared plus 2x, what is h prime of x? Sam was just here, he was about the work and he had not driven today. So, maybe someone came to pick him up. Okay, anyways, and I have a mallet, so I'm virtual for no reason, but oh well, just in case someone shows back up. Okay, sorry, side note, h of x. Okay, so we need to rewrite this as something to the 1/3, because as it is right now, we don't take the derivative of cube roots, do we? So, I'm going to rewrite my original problem as x squared plus 2x raised to the 1/3. So, Nathan Pepper answered this question, what is it? What is the